Hello Precalc. Here is a very quick video about the parameterization of the conic sections. We studied parametric equations back in November. So here we go. These two problems, there's a worksheet called Parameterization of the Conic Sections, and here is the first two problems from that worksheet. And actually both of these problems are very simple. In period 3 we did it sort of very fast, and in period 4 and 6 we just kind of didn't at all. You almost don't need to watch this video because actually everything I'm about to do is completely review from November with maybe one tiny little extra twist. And okay, we begin. Here is a problem. Suppose you didn't sort of know anything and you just were seeing this for the very first time. What might you do? Well, we can notice that sine and cosine both have period 2 pi. So this thing is going to repeat every 2 pi. What can I say about cosine t? Well, it's always between -1 and 1, so 3 cosine t is always going to be between -3 and 3, so 3 cosine t plus 4 is always going to be between 1 and 7, and thus the x-coordinate is always going to be between 1 and 7. Similarly, sine t is always between -1 and 1, so 5 sine t is always between -5 and 5. So 5 sine t minus 2 is always between -7 and 3. That tells me that my x-coordinate is always going to be between -7 and 3. Once again, you don't need to know sort of anything about the conics, maybe, to do what we've done so far. Okay, sorry, that should say why. Great. Well, what's next? Well, we have to eliminate the parameter somehow. And, okay, we sort of stumbled upon this a little bit back in November, back when we sort of didn't really know anything. The fact that we stumbled upon was that that x equals cosine t, y equals sine t is the parameterization of the circle. And why? Because it's built into the very definition of sine and cosine that a particular, in fact you can think of t as the length of the arc on the unit. You should think of it that way. If t is the length of the arc on the unit circle that you've sort of wrapped around that circle, then the coordinates of that point are cosine t comma sine t. That's actually just what sine and cosine are. Cosine is the x-coordinate and sine is the y-coordinate. And so what? Therefore, if you give me this pair of parametric equations that sort of describes for a given value of t, all the points on the unit circle. So if I understand, I'll put a little box around this, if I understand this, and this was part of the understanding that we got in November, then I can make some sense of this just from sort of looking at it. I see, well, what is 3 cosine t then? That's going to be kind of like a circle, but which has been stretched out by a factor of 3. And this horizontally. And this is like a circle, but the y-coordinate has been stretched out by a factor of 5. And also the x-coordinate and the y-coordinate have been sort of shifted by some amount. So, okay, this is all kind of coming together, and maybe this is just so obvious that it doesn't need to be said, but this is going to be an ellipse. And in fact, this is sort of another kind of perspective on ellipses. What are ellipses? They're sort of just stretched out circles. And what we now do, let's see, kind of running out of room a little bit here, but what we can do is use the identity which says that cosine squared t plus sine squared t equals 1. Of course, that is just the Pythagorean theorem, applied to this triangle, because this is just a right triangle with hypotenuse 1 and this is cosine and this is sine. Okay, so anyway, so what? Well, I'll tell you what, you can just solve for cosine, right? Subtract 4 and divide by 3. So what is cosine? It's just x minus 4 over 3. And what is sine? Sine is just y plus 2 over 5. Okay, so you could have done this back in November had I given you this exact problem, but now we're sort of more confident and comfortable with this equation, understanding just from looking at the equation in this form exactly what it means, and what we know is that it's an ellipse. So there's all sorts of things going on here at once. You know, we defined an ellipse geometrically as the shape formed when a plane intersects a double cone at a certain angle. We then looked at the definition of the ellipse such that the sum of the distances to the foci is constant. Last class we unified those two definitions by showing that they're describing the exact same thing. Here's yet another, and then of course we derived the equation of an ellipse based on the two focus definition. And so when I see this equation, I recognize that it is in fact an ellipse. And so the other kind of connection is that we already saw ellipses back in November. What are ellipses from another perspective? They're just circles which have been sort of stretched out uniformly in the x and y direction by sort of different factors. Okay, well that's it. Now the only thing left to do is to just graph it. And yeah, what do we get? We get an ellipse which has been stretched out by 4, which has been shifted over 4 and down 2. So there is my, there is my, my vertex, 4, negative 2. And then the x-coordinate has been stretched by a factor of 3, the y-coordinate has been stretched by a factor of 5. So where are the vertices? They're going to be up 5 and down 5. So let's see, 2, 3, 4, 5. So I'll have one vertex down here at 4, negative 7. Another vertex up here at 4, 3. And then it has been stretched horizontally by a factor of 3. So I get these kind of other points that don't have names, the endpoints of the minor axis. And so the ellipse itself is going to look like this. And note that this matches exactly our calculations at the beginning, that x is between 1 and 7 and y is between negative 7 and 3. Okay, and now the only thing to do is to take this seriously as a parametric problem. So where am I at t equals 0? Well, if you just plug t equals 0 in there, cosine 0 is 1, so you get 7, negative 2. So I will now add in the coordinates here. This is 7, negative 2. This is when t is 0. How about when t is pi over 2? Cosine pi over 2 is 0, so you get 4, 3. So I'm here at t equals pi over 2. And okay, when t is pi, cosine pi is negative 1, so that gives me 1, negative 2. So it's all making sense. This is t equals pi. And okay, this is just going to be t equals 3 pi over 2. I guess I can just double check it. Cosine 3 pi over 2 is 0, so that'll be 4. And sine of 3 pi over 2 is negative 1, so 4, negative 7. So that's pretty much it. What are we doing? We're just going round and round this ellipse in a clockwise fashion. So okay, great. That was 4 times longer than it needed to be. Let's do this next problem. This is also just not new. We did problems exactly like this back in... let's see, is there anything else I want to say about this? There's really not anything else I want to say, but if you wanted to, for some kind of reason, what we now can do that we didn't do back in November is to say things like that A is 5 and B is 3 and therefore C is 4. And so there is sort of more analysis that one could do here. For example, there's going to be a focus here at 4, 2, and there'll be another focus here at 4, negative 6, 4 away from the center. But I don't think that's really part of the parametric problem, so it's kind of something you can do if you want to, but anyway, there it is. Similarly here, you don't really need to know anything about the conic sections to do this problem, so this is pure review. How should we do this problem? Well, once again, because cosine is always between -1 and 1, I can tell you that my x-coordinate is going to be between -4 and 4, and that my y-coordinate is going to be between -3 and 3. Okay, well, good to know. Let's skip the end behavior step because these functions are periodic. This function is period pi, this function is period 2 pi, so the thing is going to repeat every 2 pi, and now we're just going to eliminate the parameter. The simplest thing, I think you will agree, is to start with x equals 4 cosine 2t. Why is that the simplest thing to do? Because I can express cosine 2t in terms of sine t. And so what is cosine 2t? It is in fact well-known trig identity that you all should know, 1 minus 2 sine squared t. And why is this a good and organized way to do this problem? Well, because I know what sine is. Sine is y over 3. And so I get that x is 4 times 1 minus 2 times y over 3 squared. And already I have eliminated the parameter, which is one of the things I wanted to do. Okay, so what do we get here? We get 4 times 1 minus, that's going to be 2y squared over 9. 2y squared over 9. And this whole thing is coming into shape now. This is going to be 4 minus 8/9 y squared. Okay, so perhaps in November, when we did problems like this, you were sort of less confident or something about these sideways parabolas, but now, hopefully, you are not. Hopefully now you are sort of more confident. What is this? It's just going to be a sideways parabola. And you don't really need to know anything about parabolas to graph this and to complete this problem. What's it going to look like? Well, it's going to be a sideways parabola with leading coefficient negative. When y is 0, x is 4. So the vertex of the parabola will be here at 4, 0. And what else do I know? X is always going to be between -4 and 4. So this whole thing is going to kind of stop out here at -4. Where am I when x is -4? I suppose I could solve for that, but actually it's easier to also notice that y has to be between -3 and 3. This whole thing, maybe I should do this, because it's kind of a nice thing to do, right? The calculations that I did at the beginning, they were barely even calculations, they were just observations, tell me that this whole thing is going to take place within a rectangle between -4 and 4 in the x direction and between -3 and 3 in the y direction. So okay, keeping that in mind, let's figure out, well, what happens when y is 3? If you plug in 3 for y, or -3 by the way, you're going to get the same thing, which is that y squared is 9, and this becomes 4 minus 8 is -4. Okay, so I just learned that my x-coordinate is going to be -4 when my y-coordinate is 3, and also when my y-coordinate is -3. And I'm pretty much done with this problem. It's going to look like that. And once again, no real knowledge of parabolas is required per se to do this. So finishing it off, we can just get some labels going. Let's see. When t is 0, cosine 0 is 1, so I'm going to be at 4, 0. So I'll be here at t equals 0. Where am I going to be at pi over 2? If you plug in pi over 2, you get cosine pi, which is -1. Yeah, and so that's -4, 3. So I'll be here at t equals pi over 2, which makes complete sense, right? Because that's what sine is doing. It's starting down here and it's going up to its maximum in between 0 and pi over 2. And okay, then when t is pi, I'm going to get cosine 2 pi, which is back to being 1 again. So I'm going to get 4, back to 4, 0. So I'm going to be back here at pi. And then at 3 pi over 2, I get cosine 3 pi, which is -1. So -4, -3. So I'm going to be here at t equals 3 pi over 2, and then back here at 2 pi. Okay, so what is this thing going to do? It's going to jump, 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 jump. So this is a truncated parabola. This problem is something we've seen already. Now, if you armed with our sort of new knowledge of parabolas, you could do more. This is how we did it back when we sort of didn't know anything. But maybe now, I don't know, we do know things. So let's see, what's maybe a better way to do this? We could do a little bit of algebra here and write this as 8/9 y squared equals 4 minus x. Or even, well, okay, negative x minus 4. So, and then finally I could multiply by 9/8. There's no really reason why you have to do this. So you get negative 9/8 x minus 4. But if you know parabolas, and you do know parabolas now, then this would be the standard form way to write the equation of this parabola. After all, this is in y squared equals 4qx format. And all that shows is that, yeah, it's a sideways parabola. The negative here means that it's opening left. The vertex is at 4, 0, because the whole thing got shifted over 4. And if you wanted to, I'm not saying you have to or even should, but if you wanted to, you could also determine what q is here, right? Because if 4q is 9/8, then q is some gross number like 9/32. And therefore, if I wanted to find out where the focus of this parabola was, that's something I could do now. It's going to be like, a third away from that vertex, and the directrix will be here 9/32 away from the vertex on the other side. Okay, so good. The new thing on this worksheet is number 3, and I got a separate video for that. Goodbye.